Okay, for AMI J8, we are given the graph of f prime. We're also given this initial condition, and then we're asked a whole lot of information about the graph of f. So on part A, we're trying to find the values of f of -6 and values of f of 5. So first thing we need to remember is when we integrate, that means we are finding area. And fortunately, all of these regions are very easy to find the area of. So this first little area is a triangle. It's above the x-axis, so it's going to be positive. Base is 4, height is 2, so this area is going to be 4. Your third area is also a triangle above the x-axis. Base is 3, height is 2, so that area is going to be 3. And then this middle one is a circle, but it's half of a circle. So the radius is 2, so pi times 2 squared over 2 is going to give us 2 pi. The thing is, though, it's below the x-axis, so it's going to actually make it negative 2 pi. So when we are trying to find f of -6, we know what f of -2 is. And I'm going to skip over a little bit. So those are going to be the numbers on our integral. So -6 is smaller, -2 is bigger, and we're integrating f prime. So the issue is it plus or minus? So think about where your initial condition is. Are we moving forwards or backwards? So since we're moving backwards, it's going to be a minus. So f of -6 is f of -2, which is 7, minus the integral from -6 to -2, which is 4. So that's going to give us 3. And we're trying to find f of 5. Same concept, we're given f of -2. I'm going to leave some space. -2 is the smaller number, 5 is the bigger number. But this time, from your initial condition, we're moving forwards. That means we're going to add the integral. So for f of 5, we know f of -2 is 7. Then we add the integral from -2 to 5. So from -2 to 2, that's our semicircle. From 2 to 5, that is our triangle, and that gives us 10 minus 2 pi. So that is our part A. Part B, we are trying to find where f is increasing. So we just need to remember with derivatives in general, f increases when f prime is greater than 0, which is, we're just looking for where it's above the x-axis. So that would be from -6 to -2 and from 2 to 5. And that's all we need for that part B. Now for part C, we're trying to find the absolute minimum value. So that actually means what we're using here is EVT. So one other thing we need to remember is that a minimum is going to happen where f prime changes from negative to positive. Because if you think about like what a parabola looks like, the derivative is negative here and then positive here, and that is a minimum. So with EVT, that is absolute minimums and absolute maximums. So EVT says we need to include the endpoints. So the endpoints are -6 and 5. And then we would include all the critical numbers if we were really doing EVT. But since we're really just looking for absolute minimum, we just need where it changes from negative to positive. And it only changes from negative to positive right here at x equals 2. So that's the only other value we need to check. Now we did a whole lot of the legwork in part A already. We know that the value at -6 is 3. We know that the value at 5 is 10 minus 2 pi. So that just means we need to find the value at 2. So f of 2 is f of -2. I'm going to leave some space. Integrate from -2 to 2 of f prime of x dx. Since we know -2 and we're trying to find 2, that means we're moving forward, so we add it. So f of -2 is 7. The integral from -2 to 2 is -2 pi. So that means that is our value for 2. I guess I should be more specific here that this is x and that this is f of x. So what we're trying to find is the absolute minimum. So 2 pi is 6 point something. So if we do 7 minus 6 point something, that means this is less than 1. 10 minus 6 point something means that that's less than 4. So that means this is our minimum. So the absolute min is at 2, 7 minus 2 pi. I'm not sure what I just wrote there. There we go. When it says like justify your answer, this chart right here is what justifies your answer. You're showing you've checked the endpoints, you've checked the possible minimum, so that is what we need. Now on our part D, we're trying to look at f double prime. So f double prime is going to be the slope or the derivative of f prime. So when we're looking at f double prime of -5, we really just want the slope of this line. So we go down 2, we go over 4. So -2 over 4 gives us -1/2. For f double prime of 3, when we look here, there is a sharp point. And if we think about it anyway, this goes like up 2 over 1, so this slope is 2. This goes down 2 over 2, so the slope is -1. So the slopes from either side are different. So f double prime of 3 does not exist, and it says explain why it does not exist. So we're going to say because the graph of f prime has a sharp point. So that should be all that we need for our day 8. We only got one more, and we'll look at doing day 9 tomorrow.